Hey guys, welcome back to another product testing video. If you're looking to purchase a high power output pure sine wave inverter for your van, truck, RV, solar shed, or off-grid cottage, then you're definitely going to want to see this video. This 3000 watt pure sine wave inverter was sent to me by Leaptrend, a company that also makes DC to DC battery chargers like you see right here. Even though the products were sent to me for free by the manufacturer, you can expect a fair and honest review. And as my longtime subscribers know, I never push people to buy products that I show on my channel. If you like what you see after watching this video, then you can support my channel by using the provided product links in the video description area. For many people, when they're looking to purchase a power inverter, size does matter, not only the output wattage, but the dimensions. So let me go over the dimensions first. From the front of the unit to the furthest point, which is over here where the connector is for the battery cable, is 18.5 inches or 47 centimeters. The unit is 9 3/4 inches wide from this side of the flange to the other, or 24.7 centimeters. Height of the unit from the bottom of the flange to this point here, roughly 3 7/8 of an inch or 9.8 centimeters. When you purchase this unit, included is a well-written owner's manual. You also get this modular cable, which I believe is just under 20 feet or 6 meters. And this very small remote panel that has this membrane switch that will allow you to turn this unit on and off at a distance. Before we take a look at the rest of this unit, open it up, take a look at the inside, and then test it, let's go over some of the features first. This particular unit uses 12 volts DC as the input, and the output is 110. Other versions are sold in different wattages, so you would choose the one that suits your needs. The inverter does have a nice sleek design. I like the colors, the green with the black. According to the manufacturer, you should have no problem operating sensitive electronic devices using this power inverter. The front panel, which we're going to see in a minute, has an easy to read LED indicator display. This unit has multiple protection features for low voltage input, high voltage input, AC output overload, as well as over temperature. And the surge rating for this unit is 2 times the power rating. So we have a 6,000 watt surge. The one thing that this power station has that a lot of other ones don't is a GFCI protected output. Looking at the rear side of the inverter, you can see we have 2 cooling fans. Over here you have a grounding location. You would take this inside of your RV or truck and run a cable from here to the chassis ground for the vehicle. You can see the positive and negative has these nice thick protective caps. You simply squeeze the top and bottom to release them. To secure the positive cable to this unit, you can use a number 3 Phillips or a socket. When it's connected, using the right gauge for the unit that you have, take the cover, squeeze it again, and just lock it in place. Here you can see the bottom of the unit, and we'll take a closer look right over here. Leaptrend Output Wave, Pure Sine Wave, Model Series 3000. Output power 3000 watts. Input is 10.5 to 16 volts, 300 amps maximum, so that's 3600 watt. AC output 110 volts, 26.06 amps, 3000 watts at 60 hertz. USB output 5 volts 3 amps, the typical USB output ratings. Looking at the front of the power inverter, you see that there are 3 receptacles you can plug directly into, and over here you have this little terminal block that says line, neutral, and ground. You can have the wires go directly from this unit to a branch circuit. This section here, that's your GFCI indicator, USB, your remote cable would plug right here. Right here's your display. When we power it up, you'll see everything. And right over here, if you put it to the top, that's on. And if you put it down to the bottom, that's when you're using the remote connection to turn the unit on and off. Now let's take a quick look at the inside. Looking down at the top of the unit, you can see right over here, there's a bank of 12 30 amp fuses. They're the mini fuses. Unfortunately, if these ever need to be changed, you just cannot pop them out. You're going to have to desolder them from the board and solder new ones in. And right here's a little bit better view looking down on the board. Okay, let me put the cover back on this unit. With the power inverter all back together, let's quickly go over this Leaptrend DC to DC 40 amp battery charger. Keep in mind it's also sold in a 20 amp and 60 amp version. This DC to DC battery charger is designed to be connected to your vehicle's battery. So when the vehicle's running, of course your battery is going to be charging with the alternator going, and that's going to increase the voltage at these terminals. This is going to act like a battery isolator and battery charger all in one. As you can see, there are several different settings for this battery charger. It's compatible with 12-volt batteries such as AGM, flooded, gel, sealed, lithium iron phosphate, and lithium ion. Down here is another modular jack. It's connected to an optional temperature sensor that can be used with all the battery chemistries except for the lithium. So the AGM, the gel, the flooded, it will monitor the temperature of that battery. What I like about this unit is that it's compact. You have 4 mounting points, so there's many places that you'll be able to mount this inside your vehicle to charge your battery to operate your power inverter. When the manufacturer sent me the pure sine wave inverter to be tested, they also included this, and I was under the impression it was an AC input going to a DC output, and you would select the battery type that you want. I was surprised when I got it that it was DC to DC, intended for an RV, truck, van, or anything else, even a boat, that you can connect this to your alternator and have the DC output that has the correct parameters for the type of battery that you're charging. So in this video, I'm actually not going to be connecting this up and testing it because it's not what I thought it was, but I'll definitely be testing the sine wave inverter. When this charger is used with a flooded battery, gel, or AGM, it's going to have 3 different stages to ensure that your battery is charged to 100%. Your lithium iron phosphate or lithium ion batteries are going to have a battery management system in them, so you're going to have 2 stages with this unit. It's going to be bulk and absorption. For this particular unit, if I'm going to have this inside of a vehicle, on the output you're going to want to have a 50 amp fuse or a fuse very close to that value. And on the input side of this charger, you'd want to make sure that you have a fuse that's rated 60 amps or very close to it. Of course, if you're going to be using a 60 amp unit, the fuse ratings are going to be higher, and a 20 amp unit, the fuse ratings are going to be lower. 2 important things when you're setting up this unit. You see over here it says D+, then it says LC, and you can see there's like this little jumper connection here going between in positive, which is right on the opposite side of the unit. So the LC, that limits current by 50%. So if you don't want to charge at 40, you can easily reduce it to 20. And the way to do that, you would place a jumper wire between the LC and the in positive, like it shows at the bottom. In order to make sure that this unit is not charging your battery using the vehicle's battery, you want to make sure you take the ignition on terminal of the vehicle, coming from the key switch, when it's in the on running position, and you want to route it right over to here where it says D+. You don't want to use in plus, because that's going to be on all the time, and that's going to make this turn on, and it could possibly drain your battery down if the engine is not running. So you want to take the power wire going to the ignition on switch and route it right over to D+. You can use a 16 or 18 gauge wire. And the only way this is going to turn on is when that switch is in the on position, just like when the engine is running. It's going to protect the battery in your vehicle from being drained when the engine is not running. And for those of you wondering what the inside of this DC to DC battery isolator and charger looks like, here you go. And here it is looking from the opposite side. We have 2 40 amp fuses in parallel on the input side. I now have the power inverter connected to a 12 volt 100 amp hour lithium iron phosphate battery, so we can power this up and take a look at a few different things. So let's put this on. Top left corner showing the batteries at a full charge. Every one of those segments is illuminated, and we're showing 13.8 volts. Output voltage 120, 60 hertz, and that's the wattage. First, let's turn this off, make sure the remote sensor works, and then we'll continue the testing. So let's put it to here. Plug in the cord. Okay, let's push the button, make sure this works. So that's working fine. You saw the green LED remain on, indicating the power's turned on to the power inverter, and the red LED turned off. The only time you're going to see the red LED is in the event of a fault with the power inverter. So this is good. We know this works. Turn that off. Let's remove this, and let's go back to the on position there. Let's take a look at the AC output. Measure between that blade and this blade. 119.1. That I like. I like the fact that it's closer to 120 than it is 110. And over here you have line, neutral, and ground. So if I go between the top and the middle, 119.1, top and the bottom, 119.1, and those are the same. Now over here it says 60 Hertz, so let's put this over to Hertz. And let's just make sure it's going to be coming up 60 or close to it. 59.97 Hertz, so very close to that 60. Now I want to take a look at the output to make sure it's pure sine wave. We're going to check it no load and then under load. Okay, the oscilloscope is connected to the output for the inverter. Down here you're going to see the frequency in Hertz, and we'll be able to see the waveform. We turn it on. Okay, looking pretty good. 60.0000 Hertz. So 60 Hertz. Let's just play around with this to get a better look at things. Let me go over here now. Now let's take a look at this waveform under load. I have a hairdryer here. I'm going to do 3 different settings. One is around 350. The second setting I think is around 800. And the highest setting, believe it or not, is like 1700 watts. Let me turn on the hairdryer. That's 120. So the waveform is not changing. That looks good. Let's take it all the way up to maximum heat now. $1680, 1700 watts, no problem at all. When I take this outside, we'll push it all the way up towards 3000. And I want to make sure this has no problem starting inductive loads. Some of these inverters have a really big problem starting up motorized appliances and power tools. So hopefully this one doesn't have that issue. Okay, so the waveform is fine. It's definitely pure sine wave. Now the next thing I want to do is test the GFCI feature for this pure sine wave inverter. Now a normal GFCI, what it's going to do, it's going to monitor the current flow between the hot prong, which is the smaller one, and the neutral, which is the larger one. Whatever current's coming from here must flow through to the opposite side. If you happen to have a hairdryer and you drop it in a bathtub, what's going to happen, some of that power from the hot prong is going to go through the water into the plumbing, and that's an alternate route, and it's going to trigger the GFCI to disconnect power to protect you from electrocution. The majority of GFCIs in your home, which is your kitchen, bathroom, and outdoors, normally it's going to trigger around 5 to 10 milliamps, which is a very low amount of current. So you just get a minimal shock and you'll survive. According to the manufacturer of this unit, you need at least 50 milliamps in order to trigger it. So having the higher level, you're still going to have protection if it works, but you are going to have a more painful shock because it is more current. Normally you can experience death between 100 milliamps and 250 with AC. So what I'd like to do first is take this bar meter. It's a solenoid inside here. It's measuring the AC voltage. It draws around 26 milliamps. So when I check a normal GFCI inside of a home, if you go between here and here, you're going to have, let me push this in. You can hear it triggering, all right? So that works fine. You're detecting 120 volts between here, registers right there. But when you check between the hot prong and ground, it would normally trigger a GFCI. So let's try it here. No. And this is 26 milliamps. Manufacturer says you need more than 50. So now I have a setup here to test exactly how much you need for this unit in order to trigger the GFCI protection. For the test, this is how it's going to be set up. I have a wire inserted into the ground prong. It's going to connect over here, which goes to my digital multimeter. It's on an AC current range for milliamps. The other side, where the current flows through, goes to this resistor, 1.5 k ohm, 1500 ohms. And then it goes back over to here. I need to be very careful when I plug this in, completes the circuit. If there's enough leakage, it's going to trigger. If it's not enough, you're going to see the level that we're at, and then we're going to go a little bit lower with the resistance, which is going to let more current flow. So let me turn this on. Now I'm very carefully going to plug this in, right over here. Alright, so you can see 80 milliamps, and it's not triggering. And that's well above the 50. Still not enough to be really deadly, but you would get a pretty good shock from it. Let's try it again, see if it triggers. Let's go over here. 80. 80. Alright, so it's not triggering at 80. Let me turn this off. The next thing I want to do, put this to the side. Let's take off the 1.5. Whoop, pretty hot. Over here, another 47. So it's going to be 1250 instead of 1500. And that's right around 90 milliamps. So let me plug this in and see if it triggers now. Let's turn this back on. Let's try on the bottom right here. Oh, there you go. Power's off. So that's around 90. Let's turn this off. It happens quick, but doing the calculation, it comes up around 90. So if I put this back on, let's make sure it triggers every time. Yep, that triggered fast. So this pure sine wave inverter does have GFCI protection. That works. The next thing I'm going to do is take a look at how much current is being used on standby by this unit. So what I did is I opened up the circuit breaker over here, connected to the lithium iron phosphate, and I connected up a small power supply on the right to the lugs on the back side of the power inverter. So the power here that you're looking at is coming off of here. And you can see right here we're drawing just under 600 milliamps using no load, which isn't too bad. I'm very carefully going to hold this like this. Make sure I don't touch anything. This should light it. And it does. We're drawing 3.84 amps. You can see the voltage is steady. So what I want to do next is I'm going to very slowly, with the load attached, lower the voltage. I want to see at what point power is disconnected. And then we're going to repeat the test on the high end to see how high we can go with the voltage before it turns off. Now I'm starting to hear a little bit of a transformer sound at 10.7. Output's still good. 10.4. There you go. Low voltage alarm. 10.3. 10.2. Let's see what level it actually shuts off. 9. Up. There you go. Okay. So there is a low voltage cutoff when you get just under 10.5. I think it was 10.4. It started to beep. And as soon as we dropped under 10 volts, the system shut down. We're at 16 volts. 16.4, still at 16. Okay, over 16. All right. Okay, so that works too. When we got right around 16 volts, The alarm came on, and once we reached 16.4 to 16.5, the system shut down. So there is a voltage protection at the low and high end. Okay, let me plug in this load tester. Set for 3 amps. Let's take a look here. That's the power wattage. 4.9 volts, no load. Let's turn it on. Let's take a look right here now. 15.6 watts. 5.2 volt, good output. Wow, this thing's having no issue. Let's go higher here. Whoop. Right there, it quit. Okay, so 3.5 amps, not a problem coming off of this port. Okay, I have 2 fully charged 12 volt 100 amp hour lithium iron phosphate batteries connected in parallel, and then it's connected to the pure sine wave inverter. For the first test, I'm going to see if this power inverter has any issue with a high current inductive load. If you've seen my other testing videos for power stations and power inverters, you would know that if the power station or power inverter can start this saw, it will start just about everything else. So let's plug this in and see how well it can handle the load. Keep an eye right over here. And here we go. Pretty good, pretty good. Very slight hesitation, which is basically your soft start, and then it comes on full speed, no problem. Let's try it again. Okay, so that was pretty good. The next thing I want to do is see if I can place a 3,000 watt load, or just a little below, maybe 2,900 or 2,950, to see if this pure sine wave inverter can handle it. So let's give it a try. So I'm going to put the saw on first, and then once the saw is on, I'm going to add the hair dryer. Here we go. Once the circular saw was started up and then I added the hair dryer in, there was barely any difference in the power output. Everything was just really smooth. Okay, after seeing that it had no issue starting up this saw and also adding in the hair dryer, keeping it just under 3,000 watts, I decided to let it run for a little while just to make sure it could sustain a 3,000 watt output. And this is what I found. If you look at the voltage here, battery voltage is not dropping. Battery and the AC output voltage is staying really good. So let's try it again, just to show you. It cannot maintain that output. The overload protection kicked in. This is not even hot, it's just slightly warm. As soon as it kicks back in automatically, you're going to see the hair dryer come on. There you go. So this is not a 3,000 watt output continuous unit. It has no problem powering your tools and other things as long as you don't do it for more than about a minute or two. It will not have an issue. But that's a pretty low level, 2870 or 2850 from the 3000. Let me get it a little bit lower just to see at what level this will continue to run. This heavy duty soldering iron, along with this right here, and the hair dryer. Okay guys, based on the testing that I've done, I would have to say a safe area for maximum continuous power output for this unit is going to be right in the 2,500 watt range. 3,000 watts is not going to be a problem if you're going to be using a circular saw to cut some wood or other appliances or tools for momentary use, but you're not going to get 3,000 watts continuous. It happens to be one of the best pure sine wave inverters that I tested, with respect to how the inductive loads start and how smooth everything is, but you're not going to have that full 3,000 watt output. And guys, that is it. I hope you enjoyed this video. If you did, be sure to rate, thumbs up, and share. Thanks for watching.